All right, I'm going to make a video to help give a little guidance on these questions without tipping the hand too much, because I think it is good practice to kind of think a little bit through it and try and process it, but I understand when you're stuck, it's totally overwhelming. So we have these two histograms. We know that School A has 200 teachers in it. School B has 221 teachers in it. And A is asking about the medians. They tell you one of the medians is 6, one is 7. They want you to figure out which one is which. So for A, we have 200 data points, which is an even number of points, which means the median is going to be right between, or the average of, points 100 and 101. And so if we want to figure out where the median would be for A, we need to look at the heights of the bars. Well, and it's a little bit hard to tell because they didn't break it down, but it appears like this first bar has 46 people in it. Then the second bar has 48 people in it, which means we've already passed 94 people total in these first two bars, and we're looking for where the 100 and 101st data point is. Well, there's 24 people in that next bar, so we can narrow down which bar that median must be in. And then we can do the same kind of thing for Group B. Group B, we're told that the median is we're told there's 221 data points. Since that's an odd number, our median will be the single point that's right smack dab in the middle, which if you cut that in half and then find that middle point would be the 111th data point. So if we do the same kind of thing, in that first bar from 1 to 4, there are 79 data points. Then from 4 to the 7, we already have 34 data points, and we were looking for the 111th. So you can narrow down and at least figure out which bar it would be in, and I'm going to leave it there for now for that first one. You would just need to kind of support and refer to some of those things. So the second problem, or part B, digs into the mean a little bit. And originally, the graphs they made, they told us both sets of data had a mean of 8.2. So for the original set of data they gave us, the mean was 8.2. And in part B, we're talking about high school A. In high school A, originally, there were 200 teachers in the data. So the way they got that 8.2 was by taking the total for all of the teachers, dividing by 200, and that's where they got their 8.2. Well, B says an additional 18 teachers were not included with that data that was in the original graph, and the mean for those 18 teachers is 2.5. Well, now we want to combine those 18 with the 200 we already have and get the new mean. So for the original data, if you take the total divided by 200, that's where the 8.2 came from. For these 18 teachers, if you take the total for those 18 teachers and divide by 18, that gives you a mean of 2.5. Well, what we can do in both cases here is solve for the total, solve this one for the total, and now we want to combine and get the new combined total. And then we just need to divide by the combined total number of people, which would be 218, and that'll give you the new mean. Okay, this last one is definitely a little bit different type of question, a little bit of a twist on things. It says the standard deviation of the teaching year for the 221 teachers at high school B is 7.2. If one teacher selected at random from B, what is the probability that the teaching year for the selected teacher is within one standard deviation of the mean, 8.2? We really need to look at the graph for this. We want to look at, first, count how many teachers are within one standard deviation of 8.2. So take 8.2 minus 7.2 and 8.2 plus 7.2. That will give you the range that we're looking for. And so then ultimately we just want to count how many teachers are in the data for graph B between 1 and 15.4, and then divide by the total number of teachers, which is 221 for school B. And that'll give you your percentage, your probability. And so if we just total up, and some people might worry about well, what about this 15.4? Well, in this case, we're looking at the number of years they taught, which they are going to record as a whole number. I'll tell you that in kind of that first sentence, it has to be an integer. So we really can go everywhere from 1 all the way up to 16 when we're getting that total of how many, and then just do your dividing. Okay, in number 2, we're looking at speed and strength. Please make sure you've read the question, but I'm not going to read it to you just to keep this video short. They want to know, based on the relationship between the mean standard deviation and minimum time, is it reasonable to believe that the distribution of 40-yard running times is approximately normal, and explain why? Well, if this were approximately normal, we know some things about being approximately normal. The mean would be in the middle. And then for a normal distribution, we should be able to get at least 3 standard deviations generally in order to cover all of our data. If you start marking off 3 standard deviations below and 3 standard deviations above, we run into a problem with where this minimum comes into play and what it should look like if this were approximately normal. So that's the key here to talk about that. B does not really have much of a twist to it. It just says calculate and interpret the z-score. Now, we don't know that this is approximately normal, so we can't necessarily use our z-table, but a z-score is just a standardized score. It's just taking the value or the score you're looking at minus the mean of whatever distribution you have divided by the standard deviation. So here, my score, my x is the 370. Then I'll subtract the mean and divide by the standard deviation and crunch it out. And then as far as interpreting, a standardized score or a z-score in general tells you how many standard deviations above or below the mean that your point is. And we're just kind of explain that. So take a look at this value and you're just going to describe in words, oh, this means that a weight of 370 is blah, 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 standard deviations above the mean or below the mean, depending on if it's positive or if it's negative. Hint, hint, here it's going to be positive because 370 is bigger than 310. Now, part C, what they want you to do is they give you 2 players, they give you some values, and they want you to decide which is the better player. And what this is really driving at is using a standardized score. Even if we don't do anything with probability or our standard normal table or z-score anything, or a z-score table, a z-score itself is valuable because it standardizes what you're comparing. So what I would do here is take player A and player B and find their z-score for their time and find their z-score for their weight for both players. And if you do that, you should get a pretty hopefully clear idea of which of these players overall would be the better one to choose, and then just support it based on that, based on how many standard deviations above or below 0 each player is, or above or below the mean for time and for weight lifted, and that would be how you justify it. So I hope that helps. Please feel free to follow up with any other questions or more specifics, or just say, I still don't get it. That's fine. But I'm hoping this will be a little bit of a starting point if you're stuck, to give you a little nudge, at least for some of these.